Okay, we're back again for the second video in Math 196, Spring 2014. This will cover sections A4, A5, and A6. It's about fractions and powers. And again, right, we'll do some examples. Once I've done these examples about addition and subtraction of fractions, you should be able to do all these problems. Right? So when you're listening to these videos or watching the videos, have your book out and, when you do an example, pause the video, work through some of these problems, and then pick up the video again. So we'll start actually with an example that's not in the book, right? How do you just subtract a pair of fractions? And you have to find a common denominator, right? So 5, 6 minus 3 over 14. How do we find a common denominator like for that? Well, what we'll do is we'll factor these two denominators. This is 5 over 2 times 3, because that's 6, 2 times 3, minus 3 over 2 times 7. Okay, so the denominator is a little different. This one's got a 2 and a 3, this one's got a 2 and a 7. To make them the same, I need to get a 7 over here, and I need to get a 3 over there. So I'll multiply this one by 7 over 7. And we'll just turn that 2 times 3 back into a 6. And what do we need here? I've got a 2 and a 7, but I don't have a 3, so we'll multiply this one. We'll turn that 2 times 7 back into a 14. But we need that 3 there, so 3 times 3. Right? So when I factor the 6, I get a 2 and a 3. When I factor the 14, I get a 2 and a 7. 2, 3, need a 7 here. 2, 7, need a 3 there. Multiply by 3 over 3, 7 over 7. And that gives me a common denominator here of 42. What do I have in the top? Well, 7 times 5 is 35. 3 times 3 is 9. Okay, so that's pretty good. And 35 minus 9 is 26. Notice something that happens here. You can actually factor these numbers a little bit. That's 2 times 13 over 2 times 21, right? There's a common factor, 2 times 13, 2 times 21. The 2 is common, so those can cancel out, and we're left with 13 over 21. So, after you found the common denominator and subtracted, sometimes you have to simplify some more because the subtraction can give you a new factor that'll cancel out with something with common denominator. So, basically this is how you get a common denominator. You see what's in the denominators, you multiply by whatever is missing. So this is missing a 7, this is missing a 3. Okay, so that was pretty straightforward. Hopefully everybody knows how to add fractions, add and subtract fractions. This is a little bit more complicated here because now we're dealing with polynomials, right? We've got quadratics in the bottom. So to find the common denominator, what we'll do is we'll factor. Denominator. We'll factor each of them. Right? X squared plus 2x plus 1. If I factor that, what do I want? I want two numbers that add to 2 and multiply to give me 1. So that's 1 and 1. X squared minus x minus 2. To factor that, I need two numbers that add to minus 1 and multiply to minus 2. So minus 2 and plus 1 will do that. So x plus 1, x minus 2. Okay, so this is like when we were doing the previous problem and we factored the 6 in the 14. Okay, so we have x minus 3 over x squared plus 2x plus 1, which is x plus 1 times x plus 1. Minus x plus 4 on the top over x plus 1, x minus 2. Okay, so what am I missing in each of my denominators? This denominator's got an x plus 1 and x plus 1. This one's got an x plus 1 and x minus 2. So this one's missing the x minus 2. This one has one x plus 1, but needs two of them. So this is missing an x plus 1. That's a 4. So what do? We take this fraction and we multiply it by x minus 2 over x minus 2. And now that gives me the denominator x plus 1 times x plus 1 times x minus 2, and then minus, we have our x plus 4 over x plus 1 times x minus 2, and this needs another x plus 1 because there's 2 over there. Great. So I now just need to multiply everything out. I'm going to put lots of parentheses in here so that when I distribute, I know what gets multiplied by what. Great. So when we multiply that out, what do we get? We get a denominator is x minus 2 times x plus 1 times x plus 1. And what do we have in the top? Well, here we have x minus 2 times x minus 3. If you multiply that out, that becomes x squared minus 5x plus 6, x squared minus 2x minus 3x plus 6, and then minus, well, we get the same denominator here, x minus 2, that's that, and then a pair of x plus 1s. And x plus 4 times x plus 1, when you multiply that out, that becomes x squared plus 4x, oops, sorry, x squared plus 5x plus 4. Okay, so that's not too bad. Now we need to combine them. We've got the same denominator, but we have a subtraction. And so let's put some parentheses around the top. When we have a subtraction, we get the same denominator. So that's going to be my x minus 2, x plus 1, x plus 1. And then we have x squared minus 5x plus 6 minus the whole numerator over here, x squared plus 5x plus 4. So that minus sign has to distribute to each one of these things. So scroll down a little bit. X squared minus x squared is a 0x squared. Minus 5x gives me minus 10x, so this minus that. 6 minus 4 is minus 2 over x minus 2, x plus 1, x plus 1. So not much simplification can happen here. We can factor out a minus 2 out of the top. And we can write that x plus 1 times x plus 1 is an x plus 1 squared. There's really no need to multiply it out any further. Nothing cancels, nothing simplifies anymore, so we'll just stop there. Okay, so when we've got this kind of a thing that we need to simplify it, you got to factor the denominators, right? See what you need, what's missing from each denominator that the other one has, right? So this one's got 2x plus 1, so it's got an x plus 1 and x minus 2. Need an x minus 2 here, need another x plus 1 there. And then multiply everything out and combine them. Be careful about minus signs too, that's always a tricky thing. Okay, so that's common denominators and fractions. So multiplication and division of fractions, right? And again, once I do these examples, you should be able to do 1, 2, 21, 22, 25, and 26 in section A4. Okay, so how do we do this? Well, multiplication of fractions, you just multiply across, right? So, as always, when dealing with parentheses, you do the stuff inside the parentheses first. So we have 4y squared over x cubed divided by 10 times 12 is 120. Y to the fourth times x squared. Usually you write them in alphabetical order, so x is first and then y's. And then you multiply across the bottom. 3 times 5 is 15. X to the fifth and a y. Excellent. Now you can simplify inside the parentheses. So we still have our 4y squared over x cubed divided by 120 divided by 15 is 8. we've got 2 x's in the top and 5 x's in the bottom. When we cancel those out, that means we've got 3 x's left in the bottom, 4 in the top, 1 in the bottom, so we're left with 3 in the top. So 8y cubed over x cubed. That's what this whole thing inside here simplifies to. So multiplication is just across. What about dividing? Now multiply by reciprocal. Reciprocal. That's a tricky thing to spell. I think this is correct. Right, which means flip this fraction and turn that into a multiplication. So 4y squared over x cubed times x cubed over 8y cubed. So flip this fraction and multiply. So when we multiply it, you just multiply across. 4x cubed y squared over 8 x cubed y cubed. So what do we have when we simplify that? Well, the 4 and the 8 can combine to give me 2 on the bottom. Nope, when we cancel, right, we end up with a 1. Oh, something is always there. X cubed, we got 3 x's in the top, 3 x's in the bottom. Those cancel out. You're left with a 1 in each of those places. Got 2 y's in the top, 1 in the bottom. This can cancel out entirely, and that leaves me with 1 y in the bottom. What do I have left in the top? 1 times 1 times 1. So that's just 1. So this whole thing here simplifies out to 1 over 2y. Multiply across. When we're dividing by a fraction, multiply by the reciprocals, right? So flip the fraction, turn it into multiplication, and simplify it out. Okay. So what about that thing? Well, that's a messy thing. It's a fraction in a fraction. But what we've got is a fraction divided by another fraction. So we're going to have to multiply by the reciprocal at some point. We want to turn this top into one fraction and that bottom into one fraction. So what do we do with fractions and fractions? Find a common denominator for top and for the bottom. So what do we have? Put a big bar in there and a parentheses, x, y minus 3 over x. There's my top. And x squared over y squared plus, well, 4. Remember that every integer is actually a fraction, right? It's 4 over 1. We never write the 1, but sometimes it's useful. So what's the common denominator here? Well, this is an x, this is a y. What we need here in this denominator, it needs an x, this one needs a y. So what do we have? We'll multiply this top and bottom by x over x. And then the 3 over x we need to multiply by the denominator of the other thing, which is a y. Right? And now our denominators will be x times y. What about down here? Well, this is a y squared, this is a 1. We just need to multiply this by y squared to get a common denominator in the bottom. Oops, that's a plus. So a common denominator here will be y squared, and here will be xy. So if we keep going, what are we left with? This is, that's the middle one. And then at the top we have xy as our denominator. And then x squared minus 3y. And that's my x squared, that's my 3y. And what do I have in the bottom? Well, I've got a y squared as a denominator and x squared plus 4 times y squared. And now we're in good shape, right? Because what do we have? We have a fraction divided by a fraction. So what do we all do? Multiply by reciprocal. So this last thing becomes x squared minus 3y over xy times, flip this thing, y squared over x squared plus 4y squared. And what's this going to be? Well, every time you're multiplying and you've got additions and subtractions, you want to put in some parentheses so you know what you're doing. Before we multiply, we can actually see that we're going to get a y squared on the top. We're going to have this one y floating around, so we can actually cancel that out, and this becomes a y. There's two y's here and one y there. Nothing else cancels. There's no common factors anywhere, so what am I left with? Well, y times x squared minus 3y, and then x times x squared plus 4y squared. Okay. And so that's what this simplifies to as one fraction is this thing. That's x. Okay, so dividing by fraction means multiply by the reciprocal. And now a few words about negative powers. So, what's a negative power mean? Oops, a P, not a B. Negative power means put on other side of fraction. So what's going on here with 2x to the minus 3? Well, 2x to the minus 3, the same thing as 2x minus 3 over 1, and putting on the other side of the fraction means we just move it down and it becomes a positive. So 2 times x to the minus 3 is the same thing as 2 divided by x cubed. Note that the minus 3 is only on the x, not on the 2. So the 2 goes down, the x cubed goes down. So a negative exponent, you put it down onto the other side of the fraction and change the exponent to a positive one. Right, same thing here, x squared over y to the minus 4th. Well, we move this to the other side of the fraction, which means move it up to the top. Technically there's a 1 in the bottom there, but we never write the 1 in the bottom, because when that moves out, when the y to the minus 4th moves out, there's a 1 left behind. And sometimes you have x to the 17th times x to the minus 4th. Well, the x to the 4th goes down into the denominator. And what are we left with? Well, 17x is on top, 4x is on the bottom, you're only left with 13. Which you can also get just by adding the exponents. 17 plus minus 4, that gives you minus 13. So that's one way to deal with exponents. Okay. Powers raised to powers. So we have to be a little bit careful here. What's x times y quantity squared? Well, anything squared means that it's itself times itself, right? So that would give me x times x, well that's x squared, times y, and that's y squared. And that's supposed to be an x there. But x plus y quantity squared, as we saw in the previous video, means you have to multiply it by itself. Because of the additions, you have to FOIL it out. And so you end up with x squared plus 2x y plus y squared. So what's the upshot here? If you just have multiplication or division inside your fraction, you can just distribute the exponent. So x squared, y squared, this times this. If you've got a plus or minus inside the parentheses, you can't. So these rules, these problems only deal with things where everything is multiplied together. So, just multiplication. In the parentheses, just multiplication and division. The C's, E or I, we'll go with an I. It might be misspelled, but that's okay. So that means I can distribute out the power. So this thing is 64 to the minus 1/3 power times x to the 15th to the minus 1/3 power times y to the minus 9 to the minus 1/3 power. And so what does it mean to raise something to that's already raised to a power? Well, x to the 15 to the minus 1/3 is you multiply these two together and you get x to the minus 5. And y to the minus 9 to the minus 1/3, you multiply the minus 1/3 times minus 9, that gives you a 3. 64 to the 1/3 to the minus 1/3, well, we'll put it down at the bottom and say it's a 1/3. It's a negative exponent, so it goes down at the bottom. This is just one of the numbers that, well, you can look it up in a calculator, but you should also know that 64 to the 1/3 is 1 over 4, right? 4 times 4 is 16, times another 4 is 64. So 4 cubed equals 64, which means 64 to the 1/3 is 4. My x to the 5th comes down into the denominator because it's got a negative exponent. That means put it to the other side, and the y cubed stays up top. So a couple of things there then in dealing with this. One, just multiplication and division in my parentheses. That means I can distribute the minus 1/3 to each term. 64 to the minus 1/3, x to the 15th to the minus 1/3, y to the minus 9 to the minus 1/3. You multiply the exponents. Some numbers, you should just know what their cube roots are. And we get y cubed over 4x to the 5th. You can always find this with a calculator too. Okay. Here's another example. We just have, in fact, division. Right? No addition or subtraction in there. So that means we can distribute the power. So 16x to the 8 over y to the minus 2 is what? Oh, raised to the 1/2 power. That's 16 to the 1/2, x to the 8th to the 1/2, y to the minus 2 to the 1/2. A note about what the 1/2 power means. The 1/2 power is another way of writing a square root, right? So 16 to the 1/2, that's the same thing as 16 to the square root of 16, which is 4. So this will be 4, that's my square root of 16. X to the 8 to the 1/2, you multiply the 1/2 times the 8, and you get a 4. Y to the minus 2 to the 1/2, multiply the 1/2 times the minus 2, you get y to the minus 1. This negative exponent, that's a minus 1, means put it back up on the top. So 4x to the 4th y. Technically y to the 1, but we don't write the 1 very often. Okay, so again, if it's just multiplication and division inside of the parentheses, you can just distribute the power to each term, the 16, the x to the 8th, the y to the minus 2, and then simplify from there. So, roots and powers. That should be, here it is. Roots and powers. So, as we noted above, right, we have two notations for these things. X to the 1/2 is the same thing as square root of x. X to the 1/3 is the same thing as cube root of x. X to the 7/2, for example, is the same thing as x to the 7th power, the thing on top, and then the square root of that. Right? So there's a couple different ways to write these things. So 27 to the 2/3. What is that? Without using a calculator. Well, we know 27 to the 2/3. We can always break apart a fraction into a product of the numerator times 1 over the denominator, right? Which is really what we did here. This is 7 times 1/2. So 1/2 power x to the 7th. And what we know is, what's 27 to the 1/3? Well, we can put that inside of a parentheses and put the 2 out here. So if you think about going this way, from right to left, what would you do? You'd multiply the 2 times the 1/3, and that give you 2 times 1/3. But you can also go the other way. Say if I've got 2 times 1/3, I can say 27 to the 1/3 first, and then square it. 27 to the 1/3 is 3, because 3 times 3 times 3 is 27 squared, so we get 9. So that's one way to find, without using a calculator, what 27 to the 2/3 is. You can always break up a fraction in this way. And do we have, multiplication of square roots or other powers. If it's the same power, you can just combine them together. So this is writing it in square root fashion. You just multiply the things together. Oops. Sometimes it's more useful to write the root at the end. And so what do we have? Well, 3 times 27 is 81. X to the 5th times x cubed. Well, I've got 5 x's here, plus another 3 x's, so that's an x to the 8th. Square root. And the square root of 81 is 9. Square root of x to the 8th power is x to the 4th power. We can also think of this in a slightly different way. That's 3x to the 5th to the 1/2 times 27x cubed to the 1/2, and that's a 5. Because these are the same power, we can combine them in one big fraction, and we get 81x to the 8th. And what have we learned about dealing with powers? This is all multiplication in there. 81 to the 1/2 times x to the 8 times 1/2, which is 4. And 81 to the 1/2, that's the square root of 81, so 9x to the 4th. And so that brings us through to the end of section A6. The next video will be on A7, which is solving quadratic